Hello, my name is Rob Reynolds, and this is Mat-073, where today we're going to be looking at section 1.5, intersections, unions, and compound inequalities. So we're going to be graphing solution sets on number lines, looking at our and or statements. So for an and statement and or, they're both called compound statements. They're joining two statements together. The and symbol will look like this is the intersect symbol. You can remember that the intersect symbol is the and because you can write the word and then the or symbol is the union symbol, which you can write the word or from the union symbol. And statements, the graphs will come together. It's also a between statement, so it's everything in between those values. And the or statements will be everything to the left or everything to the right. We'll keep exploring some of this. So first of all, for the intersection, again, you can remember this is intersection because you can write the word intersection with the and symbol or intersect symbol. And again, there's the intersect, but the and means everything that they have in common. It's what they both share. So it's the intersect. And so for set notation, I'm looking for, well, A is shared in both and E is shared in both. So A and E would be the intersection or the solution for this. So this is the and symbol, things that they both have in common. So and is a conjunction statement, and we can join these two statements with this word and. 9 times out of 10, I can also write it as putting the lower number on the left and using less than signs. So I believe this statement would be the exact equivalent of this statement. And again, you can see that it's a between statement. So that's exactly what we want. We want all the values in between -1 and 3, and that's why I would shade everything in between. So 2 is in between there. 1.7 is in between. Another way to look at this is if I want all the values of x that are greater than -1, because that's what this says, x is greater than -1, that's everything off to the right. This is x is less than 3, and then the things that they have in common is in between. So that's the overlap. So again, this symbol is the intersect symbol. It means and for math. So they're going to write this. We'll treat this as two separate problems. We're going to solve inequalities like we learned in the last section. When you subtract, you do not flip the inequality sign, only if you divide through by a negative. If you just divide, this also does not flip the inequality sign. Even though you see a -4 out here, it's only if you divide through by a negative will you flip the inequality sign. So we have an and statement, so I'm going to explore this over here. Undoing what's happening to x, I'll divide both sides by 3. Again, I do not flip the inequality sign when I divide by 3. It's only when you divide by a negative. So I'm going to try to graph this. I need values of x that are greater than -2 and less than 4. So I would graph it like this, and again, and statements 9 times out of 10 are going to be a between statement. So if you can be equal to it, we'll close the dot. I can accept those values, and if it's just less than, it's an open dot. But in the last video, we learned instead of doing open and close dots, I can use brackets and parentheses. So you may want to watch the previous lesson where we learned how to do this notation, interval notation. So again, this can be written in interval notation as -2, all the values between -2 and 4. So I'm including the -2 in the answer, but I can only include 3.999. I can't include 4 in the solution. So it's possible to have nothing intersect, and that would be the empty set. An example of that might be solving here for x is greater than 5, and at the same time, I'm going to add 4 to both sides. X is less than 1. Well, if I look at the graph of this, x is greater than 5 is over here, and x is less than 1, there is no overlap. This looks like an OR statement, but this is an AND statement, so I'm looking for things that they have in common. They have nothing in common, so therefore I would say it's the empty set, and this is the symbol for the empty set. Moving on to union. You can remember that this is union because you can write the word union with the symbol. You can also think about this being the OR statement. So this U could be written as an OR statement. And OR means it could be over here or it could be over here. So it's pretty much everything. So that's why our graphs will look like everything over there or everything over there. So an example of an OR statement would be everything less than 2 or greater than 8. So if I want less than 2, it would be off there, and greater than 8, it would be off in that direction. So again, this symbol is the union symbol. And we'll look at an example. If I subtract off 1 from both sides, I'll get a 2. If I divide both sides by 3, I'll get -1. Here I have to divide everything through by 2. And let's see if we can graph this. I need x is greater than 1, and it could be equal to it. So instead of drawing an open dot and then closing it, let's see, I could do a bracket. It could be greater than it. And then over here is just not equal to it, so parentheses and less than. So bracket, everything to the right, parentheses, don't include everything to the left. Some applications of this would be is if I give you an equation used to convert dress sizes in the United States to dress sizes in Italy, we'll let that be I, and it says that I is in between, and you can use that 3L rule. Put the lower number on the left and use less than signs. So I'm going to use less than signs here. Put the lower number 34 and 52. This is a between statement. So when you graph this thing, it's going to look like this. So between statements are everything over here and here at the same time. So it's an and statement. So the first thing you want to do is just kind of familiarize yourself. It looks like we have a working model already. We want 34 is less than 2 times s plus 10, which is less than 52. So we're left with the task of trying to solve for this. Well, to solve for this, I would go ahead and distribute the 2 up. It looks like this author was just kind of thinking, well, if the dress size was 8, then what would that look like? But I would go ahead and solve this by saying 34 is less than 2s plus 20, which is less than 52. I'm going to subtract off 20 from every term. So I'll look like 14 is less than 2s, which is less than 32. And then if I divide every term by 2, we'll get 7 is less than s, which is less than 16. And then if it asked me to graph that, then I would do a between statement. Good. Looks like the author has the same thing. And then if it's a word problem, we usually state our final answer. Dress sizes between 7 and 16 in the United States correspond to 34 and 52 in Italy. So sometimes when you end up with these compound statements, sometimes it's easier to break them up. So on the last problem, I didn't break it up and write 2 statements. But this is a less than symbol, but we could think about it as a less and instead of a less than symbol. So an and statement is the word that I'll put in between here. So I'll say 3 is less than 5 minus 2x, and 5 minus 2x is less than 7. And sometimes students find this a little bit easier to think about this as 2 problems. So if they give you to you in one statement, you can remember this symbol means and, because it's a play on words, less and statement. On the next example, I'll give you this. We know this is a greater, but I'm going to pronounce it as great, or, and that'll be my or statement. We'll look at that in just a moment. So if they use less than signs, it's going to be an and statement. And I already know that the graph is going to look like this. It's going to come together. But let's go ahead and find out what those values might be. Subtracting off 5 from both sides, negative 2 is less than negative 2x. And here's an example where if I divide by a negative, I'm actually going to flip that inequality sign. So instead of less, it becomes greater than. And I really don't like 1 on the left, so I'm going to flip this one more time and say x. The arrow still points to the x, so it's less than or equal to 1. I have an and statement. So let's go find the other value of x. Negative 2x is less than 2. Divide through by negative 2. When I divide by a negative, this inequality sign should flip. So it's greater than negative 1. So it's an and statement, so it should come together. X is greater than negative 1. Looks like it's over here. But this would be an open dot, or as we've learned before, the parentheses. And then this would be a positive 1, which would be the bracket. So I could either graph the solution or I could state it in interval notation. I cannot include the negative 1, put the lower number on the left, and then the interval goes all the way up to 1. So there's the solution, and I guess this problem didn't ask us to graph it. But remember, you can write this solution as the 3L rule by putting the lower number on the left and use less than signs. I'm not a fan of this solution because they use greater than signs, but this is the correct solution, but they didn't put the lower number on the left. So I would avoid this scenario. This looks good here. So if it's an or statement, you cannot write this as one statement like we did for the and statement. They combined everything into one statement, which I generally recommend that you break up into 2 statements. The or statement will always be broken up already into 2 statements. You cannot write it as one statement. So solving this, I'll add 5 to both sides. I'll divide through by negative 2. And when you divide by a negative, the inequality sign, less than, flips to greater than. Don't leave the negative in the denominator. Let's either put it out front or up top. Over here, I'll add 3 to both sides, giving me x is less than. I do not change the inequality sign for less thans. And remember, this is an or statement. So the graph of this would look, although they didn't ask me to graph it, that would go off into opposite directions. But here they just asked me to solve. So the solution of this thing would say everything to the left of negative 7. So I'm starting with this, putting the lower number on the left. So actually this goes to the left. So it goes all the way to negative infinity, all the way up to negative 7, and I cannot include the negative 7. And then or is the union, in union with everything starting at negative 3/2 and moving to the right. So that would be positive infinity. So again, on a number line, it's sometimes a little bit easier to look at. This would be my negative 7, and this would be my negative 3/2. So to describe everything over here in yellow, I say from negative infinity to 7, and then to describe everything over here in pink, that would be this solution. So this, again, this problem didn't ask me to graph it. It said solve. So the solution of this thing is sometimes a little bit harder to describe than even the graph of it, but I want you to feel comfortable with interval notation. You can also put this in set notation here. Students aren't as apt to do that because it takes a little bit longer to write, but interval notation is probably the way we want to go here. So last example, for an or statement, again, we're going to just treat this as 2 separate problems the way that it was given to us. I'll divide through by 3. Here, if I subtract off 9 from both sides, I get 4x is greater than or equal to negative 8. The mistake that students make here is they see a negative, so they think that I'm going to flip the inequality sign, but don't do that. It's only if you divide or multiply by a negative, and I'm just dividing by 4. So this inequality sign stays the same. So looking at the graph of this, which again, they didn't ask me to graph it, but sometimes it's helpful to look at this first. I want the values that are greater than -2 or less than 5. Well, less than 5 is everywhere over there. Greater than keeps going. Remember, this isn't an and statement, so it's not just what they have in common. It's everything to the left here, or could be everything to the right. In fact, I think this is everything. I think all real numbers is going to be the solution set here. And the symbol for all real numbers is like a paragraph sign, but you make it into an R. Another way to write all real numbers is everything from -infinity, everywhere over there, all the way to positive infinity. So for interval notation, -infinity to positive infinity. I hope you found this video helpful. Email me with your questions. Thank you.